Hello guys, how you guys doing? What's up? You're welcome to Edumat Up. This is the past question section of our just concluded topic, which is friction. So we're looking at some past questions. Okay, this is what you want to do right now. So the first question here is: an object of mass 20 kg slides down an inclined plane at an angle of 45 degrees to the horizontal. Okay, you have to find the coefficient of friction. Okay, if you watch the previous video, okay, I implore you guys to watch that video so you can really understand this better. The body is on an inclined plane, so let's draw the inclined plane. The inclined plane will look something like this. This is the inclined plane here. Okay, so the body is right here, and this is the angle that we are told in this question. The angle is 30 degrees, so this is 30 right here. So anytime you have a body like this placed on an inclined plane, okay, the coefficient of friction mu is straightforward. Just look at the angle of the inclination, which is 30 degrees, then just do tan 30. Just do tan 30 degrees, the tan of the angle of inclination. So tan 30 will give you 0.5771 and so on. Okay, now if you look at the options, 0.2 cannot be the answer, 0.5 cannot be the answer, this cannot be the answer, this is the final answer. Okay, when you approximate this, that will give you 0.6. so this is just the answer right here. So you just pick this as your answer. Okay, so the answer is option D. Now move to the next one. The coefficient of friction between two perfectly smooth surfaces is dash. Okay, in the previous video I told you guys that coefficient of friction acts between two surfaces. So when two surfaces are in contact, it gives you the magnitude of the friction. Now if the surfaces are perfectly smooth, coefficient of friction will be 0. Okay, that means there is no friction, or the friction is very small. So the coefficient of friction is 0 for two perfectly smooth surfaces. Okay, move to the next one. For this one, we are told that which of the following could be effectively used to reduce friction. So you have petrol, kerosene, grease, and water. I told you guys that to reduce friction, you have several methods. You have streamlining, ball bearing, and so on, and you have lubrication. So you use grease or oil to reduce friction. So the answer is grease. Okay, now next one, we are told that a 100 kg box is pushed along a road with a force of 500 newton. Okay, if the box moves with uniform velocity, the coefficient of friction between the box and the road is dash. So this is very straightforward. This is just the body right here. Okay, it's not an inclined plane right now. The weight of this body acts downwards, and we are told that the mass of this body is 100 kg. So the mass is 100 kg. You multiply that by 10, W is equals to mg. So 100 times 10, that will give you the weight. So the weight of this body is 1000 newton. So the weight acting downward is 1000 newton, and the friction is acting like this. This is the applied force. So just use the coefficient of friction. The formula will give you mu equals to F applied force divided by the weight. So applied force in the question is 500 newton. So you write 500 here divided by 1000. So you are dividing this by 1000. So this 2 will cut out. So you have 5 divided by 10. 5 divided by 10 will give you 0.5. So this is the answer here. Now let's move to the next one. On this next one, we are told that this body is on an inclined plane. You can see the body right here in the diagram above. What are the forces acting on the block along the plane? I told you guys in the last video that when the body is acting on an inclined plane, there are some forces acting on it. The component of the weight acting downwards. Okay, it does not have any effect along this direction. This direction is at 90 degrees to it. It only has effect in this direction. And component of this weight in this direction is mg sine theta, and the friction acts at the back like this, preventing it from coming down. So this is the frictional force F. So this is the component of the weight acting in this direction, down like this. So component of weight in this direction, which is mg sine theta, and the frictional force are the only forces acting in this direction. This weight does not have any effect on in this direction. Okay, it has an effect in this direction, but the component of the weight in this direction is mg sine theta. But this component of the weight, mg cos theta, this one is mg cos theta, it does not have any effect on this body. This body is sliding along the plane. The only effect on it is the frictional force and mg sine theta. this force does not have any effect on it. So let's check the options. So mg sine theta and the normal reaction. Okay, this normal reaction cannot be acting on this body in this direction. So any option that has normal reaction, okay, cannot be the answer. This one has normal reaction. This cannot be the answer. This also cannot be the answer. Okay, this one has frictional force, but it also has mg cos theta. Mg cos theta is acting like this. It's not acting like this. You need what is acting like this. So the only answer is mg sine theta and the frictional force. So the answer is mg sine theta and the force of friction, which is option B. Okay, straight up. Now we'll move to the next one. For this next one, we are told that a load is pulled by a rope of 45 degrees to the floor. If the force on the rope is 15 Newton, what is the frictional force on the load? Okay, so this force is inclined, it's acting on an inclined direction. So you have the body like this, then you have the force acting like this. Someone is pulling it like this, but the inclination of this force to the horizontal axis is 45 degrees. So this force that the person is using to pull it is 1500 Newton. So you need to find the component of this force. You need to find the component in this direction. You have to resolve this force to horizontal components. The vertical component is not needed. You need only this component. Okay, just like weight, the vertical component is not useful when you're in an inclined plane. So the component of this force in this direction is 1500 times, then you look at the angle, cos the angle is 45 degrees. Okay, so if you press this to calculator, you will get 1060.6 Newton, which is 1061 Newton approximately. So this is the force in this direction. Okay, but the friction is acting backwards like this. So both of them are equal. Okay, the force trying to prevent this body from going forward is the same as the force preventing it from going backwards. Okay, so the friction is acting backward, trying to prevent it from going forward. So both of them are equal. So the force acting in this direction, which is the friction opposing the motion, is 1061 Newton. So 1061 Newton is the final answer. So just move right here and shade 1061 Newton. So I hope you enjoyed this quick video on frictional forces. If you like this video, please give it a thumbs up, share with your friends, like and subscribe. Okay, and watch this next video on your screen. Thank you for watching. Goodbye.